So this is for this lab is for my calculus class while we practice logarithms, and this is practice lab 2, which out of the two labs is the harder one, but I want to do this with you. And I kind of put at the top here some things to remember. One is, remember, the log of 10 is 1 and the natural log of e is 1. And in this course, we're only going to use natural log to solve equations. Here's our steps to solve. We're going to use normal math first. We're going to natural log both sides, and then we're going to use our log rules. And remember, there's 3. The log rules are the natural log of a to the x equals x natural log of a. The natural log of a times b is natural log of a plus the natural log of b. And the natural log of a divided by b is natural log of a minus the natural log of b. So you can stop the video and copy that down. It's just kind of a quick refresher. I also put this here as well, that if I'm trying to combine exponential functions, if my exponents match or my bases match, you can rewrite it. So here I have 2 to the x over 3 to the x. You can write it as 2/3 to the x. Or if you had, I think you're more used to this, where you had x cubed over x squared, the bases match, so you can subtract your exponents. So that's just a quick reminder that you can combine that. So that's going to help you with your algebra. So I'm going to kind of get rid of this so it doesn't get too confusing. All right, so let's look at our first one here. So I'm going to try to change up colors. And I have 5 times 1.014 to the 3t equals 12. So I always try to do normal math first so I can see I can divide by 5. So if I divide both sides by 5, I have 1.014 to the 3t equals 12 divided by 5. When I look at this and there's no more normal math to do, then I'm going to start natural logging both sides. So let's natural log this side, natural log this side. And as soon as I do that, I have 3 log rules. So now I can bring this exponent down front and write it as 3t. Natural log of 1.014 equals natural log of 12 over 5. And you can put the parentheses there if you wish. And since I'm solving for t, the 3 and the natural log 1.014 are hooked by multiplication. So I'm going to divide both sides by that. So I end up getting t equals the natural log of 12 over 5 all over 3 natural log of 1.014. And you have a fraction button on your calculator. Put it in just like that. Just be aware, every time you hit the natural log button, they're going to put parentheses here and here. And I have you round to 4 decimal places, so that's 20.9901, but make sure you practice that. Okay? The next one here, there's quite a bit of normal math to do. The first thing is, remember, you can go different ways. I can either divide by 5 or divide by 8. I'm choosing to divide by 5, so don't think that you have to go this way. There's more than one way to solve a lot of these. So now I have 1.15 to the t equals 8/5. And I know it's understood multiplication between the 8 and the 1.07, so I'm going to make sure I put that there. So I see what I'm doing. Now you could start logging it here, but there is more normal math to do because I can divide by this because the bases aren't the same, but my exponents are the same. So I can actually write it like this. 1.15 to the t over 1.07 to the t equals 8/5. And then because there's a both raised to the same power, I can write it as a division, all raised to the t equals 8/5. So I'm done with my normal math. So I'm getting so it looks more condensed. Now I'm going to natural log both sides because I'm solving for t. I can now use my log rule and bring it down, and t natural log 1.15 over 1.07 equals the natural log of 8 over 5. And then the t is hooked to this glop, as I call it, by multiplication, so I can divide by this glop. So I have t equals natural log of 8/5, and I wouldn't reduce anything or do anything else, just do it right at the end. And so I want to write it like this. I put it in my calculator like this, and I come out with 6.5185. Okay? Number 3, this is where it gets fun. Let's look at number 3 here. Whoops, sorry. Why is it doing that? I see I can do some normal math and divide by 58 on both sides. So now I have e to the 4t plus 1 equals 30 over 58. Now I can't do any more normal math. I can start natural logging on both sides. But because the natural log of e is 1 and they undo each other, I can say thanks for playing. And that essentially is gone. I can write this side as 4t plus 1 equals the natural log of 30 over 58. Then, actually, this is not bad to solve because the natural log of 58 is just a number, 30 over 58. So I'm going to subtract 1 on both sides and then divide by 4. So I have 4t equals the natural log of 30 over 58 minus 1, divided by 4, 30 over 58 minus 1 all over 4, and then I just put that in my calculator to solve for t, and I get negative 0.4148. Okay, there's 3 of them. We're going to keep going, so if you want to try some and then come back, that's totally up to you. I'm going to do some normal math here, so I'm starting to get the hang of this. So I think what I'm going to do is divide by 18 and divide by that because they both have the same base. So I have 17 divided by 18 is going to equal e to the 0.03t divided by e to the 0.02t. And because they have the same base, I can write this as 17 over 18 equals e to the 0.01t. Now, if you went the other way, everything would be flipped and this would be negative. It still works. So now I can't do any more normal math. I'm going to natural log both sides. Thanks for playing. So I have the natural log of 17 over 18 equals 0.01t. So when I solve for t, I'm just going to divide by 0.01. The natural log of 17 over 18 divided by 0.01. And I go 4 decimal places. It's negative 5.7158. I just go 4 decimal places just because it makes it accurate. Okay? Number 5. Ooh, this one looks crazy, but it looks like I can do a little bit of normal math. I can divide by 44, or I could divide by 50. Doesn't matter. Whoops. So now I have e to the 0.015t equals 50 over 44. And I want to make sure that I write, because this is understood multiplication, 1.2 to the t. Okay, so now when I natural log, because there's no more normal math to do, the left is going to look all right, but I want you to realize you have a multiplication in here on the right. So you're going to have to pull that apart with addition. And over here, I can say, thanks for playing. So I have it's point, not 0.15. I wondered why that looked weird. It's 0.15. I'm sorry about that. I wasn't trying to trick you or anything. That was an accident. Okay, so now I have 0.15t equals the natural log of 50 over 44. Okay, so here's my equal signs. This is multiplication plus the natural log of 1.2 to the t. Now, some of you are like, why didn't you bring the t down right? I could, but I'm just trying to go slowly so that you can see what I'm doing here. So I have 0.15t equals the natural log of 50 over 44 plus t natural log of 1.2, right? So now this term right here has a t in it. This term has a t in it. So I actually am going to go to the left, okay, and subtract this. So I have 0.15t minus t natural log of 1.2, because they both have t's in it, is going to each equal the natural log of 50 over 44. So these have terms, this is a number, and I got the t's on one side. Now I'm always telling you guys, there's a little saying, I'm going to factor out the x or the variable, factor out the t, divide by the GLOP. So if I factor the t out, I have 0.15 minus natural log of 1.2 equals the natural log of 50 over 44. And since the t is hooked to this GLOP, I call it, right here, I call this a GLOP, but they're hooked by multiplication, so I can actually divide by that. So I have t equals the natural log of 50 over 44 divided by 0.15 minus the natural log of 1.2. And when I put that in my calculator, I get negative 3.95505. I went a little bit further on that one. All right, number 6. So I look at number 6 here and I said, oh, okay, can I do any normal math? And there's really no normal math to do. So I'm going to start natural logging right off the bat. But remember, when you natural log, okay, here I can say thanks for playing. So this is really let me use a different color here, x plus 5 on the left. But remember, here I'm multiplying, so I have to pull that apart. And with you guessed it, addition, and I'm going to do x natural log of 2. Now, if that bothers you, you can write natural log of 7 plus the natural log of 2 to the x, and then your next step is to bring the x down, okay? Now I see this term has an x in it. This is a number, this is a number, this term has an x in it, so I'm going to move this over to the left and the 5 to the right. So I have x minus x ln 2 equals ln 7 minus 5. Factor out the x, divide by the glop. So the only thing on this one is if you're factoring, you got to divide both terms by x. So you have a 1 minus ln 2. A lot of people forget this one equals ln 7 minus 5. And again, we're going to divide by this glop right here. So I have x equals the natural log of 7 minus 5 all over 1 minus the natural log of 2.
May I have your attention, please? Cody Cole.
And so then, sorry about that announcement, guys. So when I put this in my calculator, I get negative 9.95295. I went a little bit farther on that as well. Okay, we have 2 more left, and they're kind of long ones. Well, they're not, they look worse than they are. This one right here, if you were to look at this, and I put this like this, everybody's like, oh, we can cross multiply. See how the exponents match? So you can write it as 3 to the x equals 10 to the x minus 1. Because the exponents are the same, so I can multiply my bases and natural log both sides. Okay. When I do that, I get x natural log of 3 equals x minus 1. Remember, when you bring this down, bring it in parentheses down front, natural log of 10. Now, if you bring down a binomial, you have to distribute. It's like having the number behind. So I have x natural log of 3 equals x natural log of 10 minus 1 natural log of 10. Now, you don't really need the 1, but I'm just showing you that. This term has an x in it, this term has an x in it, and this one doesn't, so I kind of went to the left. Okay? So I have x natural log of 3 minus x natural log of 10 equals a negative 1 ln 10, or just a negative ln 10. Now I'm going to factor out the x, divide by the glop. So when I do that, I have x times the natural log of 3 minus the natural log of 10 equals negative 1 natural log of 10. And I'm going to divide by the glop. So here's my glop. Okay, so now I have x equals negative 1 natural log of 10 all over the natural log of 3 minus the natural log of 10. So when I put that in my calculator, I get 1.91249. And it's okay. And the very last one. So this one is going to take a little bit just because I like to write things on here. So I'm going to use blue here. I'm going to change x over 2 to a half x. And this is 1 minus x. So I'm going to put that in parentheses, and I'm putting a multiplication there, making sure I show it. There is no normal math, so I'm going to natural log both sides. So I have the natural log of, well, let me erase this, 2, sorry about that, 2 to the half x plus, because remember, I'm multiplying, the natural log of 3 to the 1 minus x equals the natural log of 4, see, I'm multiplying, plus the natural log of e to the x. Now, the cool thing about this is I can say thanks for playing there, so that's just an x. So the right-hand side looks pretty decent. The left-hand side, we got to kind of play around, and I forgot my x here. So what I'm going to do here is bring this half x down, bring this 1 minus x down. So I end up with this. 1/2 x natural log of 2 plus 1 minus x natural log of 3 equals a natural log of 4 plus x. We're getting there, guys. Now I'm going to distribute because I have a binomial. So I have a 1/2 x natural log of 2 plus 1 natural log of 3, don't really need the 1, minus x natural log of 3 equals a natural log of 4 plus x. I'm going to go through here and say this term has an x in it, this is a number, this term has an x in, this is a number, this term has an x in it. So this is where I say be smart, lazy. Since 2 of the x terms are on the left, I'm going to move that over here. So I have a 1/2 x natural log of 2 minus x natural log of 3 minus x, so I move that over, equals a natural log of 4, which is this number, minus the natural log of 3. I could put the 1 there, but I don't really need it. Now I'm going to factor out my x and divide by the GLOP. So when I factor out the x, I have a 1/2 ln2 minus ln3 minus 1. Don't forget that because x divided by x is 1, equals the natural log of 4 minus the natural log of 3. And then I'm going to divide by this GLOT because because I can divide by this. So x is going to equal the natural log of 4 minus the natural log of 3 all over 1/2 natural log of 2 minus the natural log of 3 minus 1. And when I put that in my calculator, I get negative 0.164198. So this is a long video and you can stop it and play it whatever you need. I just wanted to make sure that you were comfortable solving these logs, and I wanted to do with these in class. So you're welcome to look at this at any time.